All right, so first thing we're going to look at. Again, this is backing up just some basic stuff that probably the last time you saw it may have been like 7th grade. But it's more of they're going to give you some different things, and they're going to ask you to put them in different categories, really what this is. And this is natural numbers. And natural numbers sounds like what it is. If I tell you to start counting, what's the first number you're going to tell me? 1. There you go. So that's what a natural number is. It starts at 1, it's 2, it's 3, it's 4, and it goes on from there. Sometimes they call them counting numbers. Natural numbers, it's basically the same thing. It's where you would naturally start counting when you're going through this thing. All right, whole numbers. They kind of give it away in the name because whole numbers, it starts with a whole. Not whole W, but whole H-O-L-E. So for that one, you start at 0. And then you go to 1, and then 2, and then 3, and 4. All right, integers. Basically, it's anything that's a whole number. Whole numbers, basically, you're looking at 0 and all the positive numbers. Integers, it's taking those same things and it also lets you do negative numbers. So for these, you're going to have any negative or positive whole number, basically, if you want to look at it that way. So we got -4, -3, -1, -2, 0, 1, 2, 3, 4. Anything that doesn't have a decimal or a fraction, it's just a whole number that could be positive or negative, that's what an integer is. Okay, so those are all kind of specific things where they all kind of fit in certain little categories where they got certain amounts of them. The next two things, these are kind of the big ones that you can put all kinds of different numbers in these. Okay, rational numbers is the first one here. And rational numbers basically is this. This is any number that you can write as a fraction. Now, it doesn't mean that the number is a fraction when they give it to you. It's anything that if you can take it and turn it into a fraction, then that makes it out to be a rational number. All right, we'll show you some examples of what this can look like. Now, obviously, 1/2 would be 1 because it is a fraction. It could be -2/5. So positive or negative, it doesn't matter whether it's whole number. I mean, whether it's a positive or negative, either way is fine. It can be anything there. As long as it's a fraction, it's okay. All right, here's where they'll start changing up a little bit. You get 0.3. It's a decimal number. But can you change that decimal number and make it into a fraction? You can, right? Because what place value is that in? It's in the tenths place, right? So even though it's 0.3, if you can rewrite it as a fraction, you can make it 3/10. There you go. So that's in fraction form, so that's okay. All right. And it's one of those, again, you just stop and think about 4. It's definitely not a fraction. But how do you make it a fraction? Any whole number, you can just put it over, yeah, there you go. Just put it over 1, right? All right, what about 0.6 repeating? Now, in some of these, we're not going to worry about some of the weird stuff in these, but we'll just show you this just because it pops up. Most people remember this one. If you've got 0.6 repeating, anybody remember what that is as a fraction? 2/3. There you go. If it's 0.3 repeating, it'd be 1/3. It basically is this. If you get a repeating decimal in there somewhere, you can somehow or another change it into a fraction. You may not know what it is, and that's fine. But as long as if you see any kind of repeating part of it, it's a fraction in some way, shape, or another. I'm not worried about you making it that way. Just know that you can turn it in that way. All right, and here's one sometimes kind of sneaks up on people. 0. So, well, 0, it's it's nothing. Yeah, but can't you still take nothing and put it over 1? So it's kind of like a whole number. where we had 4, -4. It still works. It's just kind of a little bit of a trick question. All right, one more. Square root of 25. Alright, if you take the square root of 25, now by itself it's there, but just so you can kind of see here, if you take the square root of 25, punch in the calculator, hopefully everybody knows this, that's 5, right? So that's a whole number. So even though they gave it to you square root of 25, you can make that out to be 5, so even that square root of 25 is a rational number. Okay, and as far as everything I can think of, there may be some other stuff, but that pretty much hits everything you can kind of go through with rational numbers. They can give it to you in different form, but again, if you can take something that's not a fraction and rewrite it to make it a fraction, technically 5 would be 5 over 1, so that would make it a rational number. Anything you can turn and make it into a fraction, it's a rational number. Alright, and then on the flip side, if it's not rational, that's going to be irrational. And it's basically just the opposite of rational numbers. If this is any number that you can write as a fraction, irrational is a number that you cannot write as a fraction. Alright, and we've got a ton of different rational numbers, the way all kinds of different varieties and different ways you can do it. If it's irrational, there's pretty much only 1 of 2 or 3 different ways you can do this thing. Alright, first one is staring right at you. That's pi. Now, I know somebody's thinking, well, we use 22 over 7 for pi, right? Well, that's close. That's as close as we can get it on like a regular number. It changes after the 3.14. It changes after that. So it's close to pi, but it's not. But that's one of those numbers that pi, it goes on and on forever, and it doesn't repeat. And since it doesn't repeat, then it doesn't fit in that category. So pi is one of those numbers where it is irrational. And pretty much the only other things you can do for this one would be something like square root of 7. And, if the numbers start getting big with the square roots, basically it's one of those numbers that if you punch it in, and this thing goes on and on and on and on forever, like this one, it just keeps going, there's no pattern to it. If you punch it in and you get some kind of decimal number for square roots, that's going to make it irrational. So if it's not a perfect square root number, if it's not square root of 9 or square root of 16 or square root of 100 or something like that, if it's anything else, if it's square root of 2, square root of 41, if it's anything like that, it's not going to be rational, it's going to make it irrational. And basically on those, if it's a square root, you punch it in, if it comes out to be a whole number, it's rational. If it's got any kind of decimal number on it, it's going to be irrational. Okay, so after you've got, and we'll do some problems here in a little bit where we'll show you, how they kind of fit in here. The other thing they're going to ask you to do for these is they're going to ask you to order and compare numbers. And those will basically be 2 different things we're going to do. One part they're going to ask you to order it, the next part they're going to ask you to compare it. And when they ask you to compare, that means you've got to use less than, greater than, or equal to. It's going to be one of those 3 options. They're going to give you 2 numbers, and they're going to have you just fill in the blank. Which one's it going to be? Is it going to be less than, greater than, or is it going to be equal to? And probably it's one of those where they'll give you a box in the middle of the 2 numbers, and they'll say, all right, compare those 2 numbers, tell me what you get. And honestly, it's really just one of those calculator questions. I mean, most people don't have square root of 17 memorized. I know I don't. And it's one of those where you just kind of grab a calculator, just check it out real quick, and see what you get for square root of 17. That's 4.1. Oh, sorry, can't see it there. There you go. So square root of 17, that's basically 4.1. So you're comparing 4.1 and 4.3. Well, 4.3 is definitely bigger, so got to do something like that. Okay, so comparing them should be pretty straightforward. You know, we're not going to get too tricky with them. The only other thing they're going to ask you to do some of these is they're going to ask you to order it on a number line. And if you order it on a number line, that just means you got to go back and, you know, break each number down. Okay, so they'll probably do something like this, and sometimes they'll even have little boxes in here where they've got the different things, but something along those lines. All right, biggest thing to listen is again, you've got it now. The whole numbers, those are going to be easy when you got -2 and 3.5. That's going to be easy to get that in order. It's your square roots that you're going to have to kind of figure out where those numbers are and how to get them in there. So it's going to be the same thing. You're pretty much going to have to take your calculator and go back and tell me about what those numbers are. So if you do square root of 6, well, that's basically 2.4. Alright, if we do negative square root of 8, basically you can just do square root of 8 and just throw a negative in front of it. So square root of 8, that's about 2.8. So that's negative 2.8. Okay, and then from there, once you've got those two numbers figured out, then you can just go back and start putting them where they need to go. Negative 2.8 is about right there. So that would be your negative square root of 8. Alright, once you got that one checked off, then you've got negative 2, that's right here. Next thing we've got here is a half, so that's somewhere between 0 and 1. You got square root of 6, which is 2.4, so that's again somewhere right about there. And then you got the 3. Okay, so if you're ordering on a number line, really it's just the same thing as comparing it. It's just you've got 4, 3, 4, 5, 6 numbers you've got to compare, and you're just comparing them one at a time. You put the smallest one in, then you can just kind of work up and go from there. A lot of times with that one, they'll have boxes already kind of set in that they'll have an empty box here and an empty box here, and you just got to go back and put the numbers in the right place. So they'll kind of make it work out some way or another there.